In this Capstone project, we developed an intelligent movie recommendation system, using dimensionality reduction through matrix factorization. For more details, visit www.capstoneprojectshub.com. The following steps have been completed. Step 1. Problem definition and mathematical formulation. In this step, we defined the user movie rating matrix, R, with missing entries. We also identified the observed set of ratings and formulated the task of predicting missing entries as a matrix completion problem. This is the user movie rating matrix. Each row represents a user, and each column represents a movie. The numbers show how much a user likes a movie, on a scale from 1 to 5. A 0 means the user hasn't rated that movie yet. These missing values are what our recommendation system will predict. In the remaining steps, 2 to 6, we start with data setup and masking, move on to matrix factorization, then train and optimize the model. We assess its performance with standard metrics and conclude with results, visualizations, and interpretations. We present results from the matrix factorization model, focusing on training loss, matrix reconstruction, and how observed ratings compare with predictions. As figure shows, RMSE drops quickly at first, then slows as the model refines. After 1000 epochs, it flattens near zero, showing convergence, normal for small data, but a risk of overfitting in larger cases. Figure compares the original rating matrix with the completed one. Missing zeros are replaced by predicted values, for example, user 0's 3.5 for movie 2, and user 2's 3.7 and 3.2 for movies 0 and 1. This shows the system can infer preferences and suggest unrated movies. Figure shows the top2 recommendations for user 0. Since movies 0 and 1 are already rated, the system predicts about 3.5 for movie 2, making it the top suggestion and likely to match user 0's preference. Figure shows the top2 recommendations for user 1. Since they've rated all movies, no unrated items remain. The recommendation list is empty, showing the cold start limitation. Figure shows the top2 recommendations for user 2. With only movie 2 rated, the system predicts 3.7 for movie 0 and 3.2 for movie 1, recommending movie 0 first. This shows how matrix factorization works even with sparse ratings. Figure shows a scatter plot of observed versus predicted ratings. The diagonal line marks the ideal case where predictions perfectly match the true ratings. And before we dive deeper, if you want the full project documentation, source code, and ready-to-use slides, make sure to visit CapstoneProjectsHub.com, your one-stop hub for Capstone project success.